you're gonna be quiet. It's Emma's turn.
Okay.
This is the Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known.
Hi, I'm Lee Bortons, and it's Wednesday, June 22nd, 2025, which means we're 1/13th through the year, and we still can't remember to write 2025 instead of 2024 on our checks. Welcome to the Math Map Book Club, where Kirsty Gilpin and I discuss lessons each week from our math curriculum for families with students enrolled in classical conversations communities. This year, we've been working a week at a time on a lesson, and we're preparing to answer our students' questions. So Kirsty, what do you have for us today?
Well, today we are, it's kind of a big day because we're going to be talking about solid shapes, which is really what is our most familiar, right? When we think about the dimensions and we think about things, the solid shapes are the things that are the most familiar because they're the things that we can pick up and touch, whether that's our water bottles or our babies, those are solid. But it's also, right, hits that week 20. So it's going to be our last week for interesting integers before we start something new next week. So kind of a big week as we look at some things that are familiar and wrap up something that I know people have been enjoying. So of course, every week we want to take a minute and make sure we know where we are on the math map. And so here we are in the third dimension, human space, and we are looking at solid shapes. And we're using our complex curriculum. That is the curriculum that is currently out and in print and in use in our Challenge A communities. And we have made other domains available digitally. And so it's just a great reminder that all of those domains are working through the same concepts this week, dealing with solid shapes in a similar mapping. So similar problems that are going to build over the course of the year. So no matter the place that you're at with your family or with your calculation skills, you can engage in our conversation today. So for our last number, I chose the number 84. And so let's just take a minute, and why doesn't you guys share what you know about that number?
It's even.
It's even.
Positive.
Good.
Makes it composite.
Good.
What do you mean by
Relation-
big and small? Oh, good.
Yeah, I was going to say, in relation to our vast amount of numbers, it's not that big.
Mm-hmm.
It's true, right? When we think about big and small, we're always thinking, okay, compared to what? And you're right, in the terms of all the numbers that are out there, it is a small number. But in terms of our lived experience, is 84 feel big or small?
Well, if it's dollars, it's not very much.
In years, it's a lot for a
If
lifetime.
it's age, it feels old a lot.
Mm-hmm.
It reminds me of the book 1984 by George Orwell.
Well, that's good. So one of the things we might say is that when we talk about the size of a number, we need to be either compared to something else, another number, or we can talk about the size of the number based off of its units. So if we're just talking about 84, right, as a number, we might say it's not very big. But if we say 84 years, that's a long time, but 84 seconds isn't very long. And so that's a great place to really talk about with our students, right? Well, what units might this be? And which units would make it a big number and which units would make it a small number? Anything else interesting or that you'd like to share about 84? I love the connection to 1984. We read that in my 8th grade English class because it was 1984. So
I'm trying to vision it in Roman numerals, so it's
Yeah.
L X X X IV.
yep.
It's too bad they didn't use different letters because they never spell words.
Although, have you seen, it's been a meme that I've seen a couple of places now about the drama at Five Guys because the lights were out. And so, it's the word Five Guys, but the F and the E were out. And so it was the Roman numeral 4. And then in the next picture, the I has gone out and it's back to 5. So it was the drama, right? We've gone from 5 guys to 4 guys, but now they're back together again. So
Then your question about tallies makes me think of all those movies where someone's on a desert island putting tallies on a stick, knowing how many days they've been there. If you knew it was gonna be a long time, you probably wouldn't have started with tallies.
I was going to say 84 would be a big number then.
yes.
It's a great N2K, national number knockout number, because there's so many equations that are simple that it represents.
So I picked 84 because my daughter is hopefully a future rocket, and there are 84 rockets in the company because they have two show casts of 36 plus 12 swings. So when I was trying to come up with a number for today, that's why I chose 84.
So 2 times 36 plus 12. Well, we know with the expression being base 2, you don't mean the number itself, right? Because 8 and 4 can't be in base 2 because their digits are too high. But you could write
Correct.
right? But you could write
Right.
84 in base 9.
Base 2. Well, I could, but I could also say in base 2, it would be
Yeah.
right, 2 to the 6 would be 64 plus 16 would get me to 80. So that would be 2, right? I've got so I'd have 1 0 1. That's 2 to the 4th, and then 0 2 to the 8th, 1 2 to the 2 squared. So it'd be 1 0 1 0 1 0, I think.
Yes, that's correct. We math nerds are figuring that out.
All right, well, let's go ahead and move on to our cover. And I've tried to zoom in a little bit on our cover here because there's a lot of detail. I'm going to start our timer. There we go. And what would you like to share about what you see in the art? Or perhaps if you've read our quote or a reflection, is there something there that you'd like to share today?
Architecture is just so beautiful. Like it's very appealing, eye appealing. Is that, I don't know if that's the right terminology, but it just looks so put together. Like, I don't know. I think of Legos when I see this because I'm pretty sure my kids have built something similar to this when they were younger and used Legos.
Well, it just shows the mathematical ability in mankind in all cultures and all times.
It's
But lots of
interesting to me that the city is everything is so pristine and clear and just I don't know how it's described, and yet the sky is angry. Like it looks like a storm is coming. So while the city, everything looks very clean and orderly and status quo, then you have this in the horizon up above the sky. It's quite a contrast of even just shapes. Everything is lines and angles in the city, and then you have this billowing, much more out of order.
Yeah, the chaos compared to the architecture. There's lots of solid shapes. I can see frustrums and pyramids and tetrahedrons.
Frustrums. Okay. I don't know what that is. What's a frustrum?
A pyramid with its top cut off. That'd be an example.
Mm.
The one in the middle there.
Mm. Well, I was reading the St. Augustine prayer, and I am struck by how many words in there now look like math to me. I think you guys are messing with me with the whole seeing the unseen. Like I'm struck. I'm just like, oh, shadow, that's math. And strength, that's math. And return, that's math. And weariness, that's math. Like all of these words in here now look like math to me. And I'm like, I have been hit by the math map crazy people. It's just like I'm reading these terms and I'm like, wow, I don't think I ever would have thought of return in the way that I do now, like returning. Now I think of a map, or even the word with. Like I was reading it and the word with makes me think of even numbers, because an even number always has a partner, is how I explained it to my kids. And an odd number leaves an odd man out. And so suddenly everything is like mathematical, even in the words that I'm reading. And it's in some ways it's really beautiful, and in some ways it's driving my family crazy.
Thank you. I really appreciate that testimony, because that really gets to the heart, right, of what we're trying to do when we talk about classical education, is that integration, right? And for so long, math has been left out on its own as something else or something other. And yet, when we decide to pursue math without being afraid of necessarily getting all right, without having to check all the problems off, and we're pursuing the ideas of math, we see how that pursuit is going to filter through and integrate with everything else that we're doing, and add a dimension to our understanding that we wouldn't have had if we hadn't been delving into the math. So I really appreciate that testimony. Thank you.
Mm-hmm.
I just wonder if that's because of the digital age. If before everything was electronics, a farmer had to go outside and use his measuring tape to figure out things, but now he can use a satellite and he doesn't even have to go to his field to know how much lime to buy.
Mm-hmm. Yeah. Well, my
I love
11-year-old said, Mom, he said, I'm just beginning to feel weird about how the math map makes itself into, like, finds itself in all our conversations. I'm like, sorry.
I also really like the Isaac Newton quote, because in Challenge 3, we're reading in philosophy about the questions people had. You know, where did everything come from and what's it all made of? Is it all water or fire, or what is it? And to have this, that in the beginning, God formed matter, and in a way that pleased him, and that we are formed to please him. But it just ties in really neat to what we're doing in other challenge levels too.
The thing about this picture is, to this culture, mathematics was inherently religious. I mean, that's what this is a picture of, is there were areas of worship and then the commerce around it. And if you read how the Hebrews built the temple, you see the same thing. The math really mattered to the description. And we don't think about that anymore either.
Feel like you just talking about how, right, it was formed to please God in the way that pleased him, and we're formed in the way that pleases him, that Isaac Newton, right, as he describes it here, we would say he doesn't really understand matter, right? That he doesn't really understand how we understand it today, that we've been able to break it into smaller parts and things that he thought were impenetrable. Today we understand it differently. And so just because our understanding of something may be incomplete, I love the fact that God understood it and God formed it for a purpose and God formed it in the way that it needed to be. And so as people, whether we're looking at ourselves or whether we're looking at others, we may not understand ourselves, we may not understand others, but God does, right? And God has a purpose for each one of us that pleases him. And so I like that encouragement, right? That we don't have to have all the answers today, but God's purpose is still being carried out.
Yeah.
Which when I start reading the quote, anytime I start reading, "O Lord our God," immediately in my brain, I start singing, "How great thou art."
Does anybody know how to pronounce the name of this painting? No.
Looking at the actual page so I can see if I can read it more clearly.
Yeah, I'm not offering.
Is this city sitting on top of water? Or is it just near water?
It's at the edge of water, because I think if you could look farther back on a bigger version, you can see the land and mountains in the background.
Okay. Wow.
And it's very palatial looking.
Mm-hmm.
The other thing I think that's interesting is that the smallest object in the universe is about 30 times a magnitude of 30 smaller than us, and the biggest thing is like a magnitude of 30 larger than us. I think that's zeros, and that man's right smack in the middle when it comes to sizes. So there's just so much when you think about numbers and worship and glorifying God, and that we're made in his image, that you could just dig deeper into.
So the title, Conquest de Tenochtitlan, something along those lines, is translated right to the conquest of, and it made me wonder, Shauna, if that's perhaps that dark overshadowing there, the idea that there was was it imminent? Because there's no battle scene going on, but I wonder if it was imminent, and perhaps that's why that gloominess. I don't know. It would be interesting to go and research a little bit more about this and in the historical setting of it. All right. Well, let's go ahead and look at our invention page where we get to practice our skills of learning, especially those that we consider to be part of our invention canon of rhetoric. So let's start with our tell me everything question. So what do you know about three-dimensional solids? And do I need to even say three-dimensional solids, or could I just say tell me everything you know about solids?
It helps me to hear three-dimensional solid.
But is there such a thing as a solid that's not three-dimensional? Is that what you're asking? And is the answer no?
I don't know.
Huh.
So could we have a four-dimensional solid that we simply don't see the fourth dimension of?
I would hope so. But So if there wasn't one, then I'd be worried because it would break the pattern.
I would
But we
think
could-
that it has to be at least three-dimensional.
Mhm. Yeah, because we've talked about the only two-dimensional thing in our universe that I can think of, no one else has given me one, is a shadow. Everything else has a backside, whether you want it to or not.
Hmm.
So I think what's familiar is one, the shapes on the artwork. They were definitely used.
If
I
we
would-
were if we were in our challenge class, how could we help our students to think about this? What are some solids that they're familiar with that may even have a similar shape to the ones that are on the page? What are some things our students might be familiar with that look like a sphere?
Soccer balls.
Yeah, any balls. Yeah, any type of ball that they like to throw at people.
Yeah.
I say the tissue box now because everybody's sick. Everybody around
True.
us is like not like we had so many out yesterday because everybody was sick. So I just think of the tissue box with the cube.
Hmm.
When I look at all the books behind all of your images here.
Hmm.
And then all of the citrus fruit that we're eating right now to get our vitamin C with our sickness would be like the circle sphere. I mean,
I know I spoke with Babs yesterday and she referenced her Challenge A class working on their maps. So what might you use during your debate strand looking at geography that looks like a sphere?
Globe,
Globe. Yep.
or even one of those blow up globe balls that you can toss around the classroom you buy at the Dollar Tree.
Yep.
Yeah, I think globes were more familiar to the last generation than they're going to be to this one.
I'd say the beach ball globe is probably the one they probably relate to more than a real nice globe.
I went out and bought an actual globe. Well, actually, I I asked on some group I was in, or maybe it was my husband, if anybody had a globe they want to give away because the globes are so expensive. I was like, I'm sure there's somebody who doesn't have one. I mean, who has one who isn't using it. And sure enough, I got a really nice globe. But my point is, my kids hadn't seen a globe in years because we left the last one we had in Chicago for some reason. And now I make them point out the places on the map that we do, like in foundations, and I have a challenge day on the globe, and the questions have just been amazing to me. I'm like, oh my gosh, this is, I don't even remember anybody telling me these things before. I think I just like absorbed them or picked them up because we were always looking at a globe. So yeah, I think that's true that a lot of people don't look at globes for whatever reason.
Yeah, well, everything's digital. And the thing so great about a globe or any 3D shape is it does have a backside. And so since we're bigger than those objects and the ones we're talking about, we can see front and back. But we obviously we can't do that with our own globe. We can only see a little bit around us.
Mhm.
So that shows you your perspective changes based on the size of things.
Oh, and then perspective is math. Yeah.
So Nicole, I like what you're saying, because I think what you're suggesting is that there's a big difference between looking at locations on a map to looking at locations on the globe, right? And so where we've been talking about all of this stuff in 2D, when we take things that are really supposed to be three-dimensional and we look at them in 3 dimensions, it gives us a whole different level of understanding that two-dimensional representation loses something, right? And so I think that's an important thing as we're talking about 3D. That's an important thing to remember, that 2D is oftentimes easier to work in because we can lay it out in front of us. But just like that shadow is only going to tell some of the story, right, about who I am, a flat map is going to be limited in helping us to really fully understand and appreciate what our Earth looks like. So my son actually bought himself a globe a year or so ago because he found an old globe in a like one of those sort of thrifty stores, and it showed more of like the British Empire all over the Earth. And so that was really kind of cool to see a historical globe and how things have changed since then.
So tell us about, we're probably all familiar with the 0D to 4D idea, but tell us about this bounded and open and intervals. Those words, I thought I knew them until I met you, Kirsty. So explain this to us. They're familiar words, but I didn't know them accurately.
So sure. So when we think about, well, let's look at that. Let's look at bounded and unbounded in the middle there. And what does, if you look at those and use your skills of comparison, what are some things that you might think about when you think of something being bounded versus unbounded? What does that mean to you?
Well, in the 0D and 1D, the bounded have endpoints. There's the dots, where the unbounded is at least a ray. So it might have one end, but it continues on.
Good. So when we think of something being bounded, we think of there being something finite about it, right? That there's I think of the Bible verse in Job where God says, right, like, have you told the seas how far it can go, right? That there's a boundary. God's saying there's a bound, right? And I'm the one that establishes that bound. So in mathematics, right, I can put and if you were to continue on, right, way past the math map and go on into, you know, advanced studies in math, one of the things that they do to understand different functions is to say, well, what are the bounds of it, right? And maybe there's two functions that I do understand that are boundaries to this third function I don't understand. And so that idea of a bound is something that says, this is the limit. It cannot go past this, and it can't go past this. And so it might be an endpoint on a segment, right? That's a bound. And if you look at that ray, right, it's only bounded on one side. So it's unbounded, but if we were to be expressing that algebraically, I might say it's bounded below, but it's not bounded above. So it's bounded on one side, but not the other. When we look at our other shapes there, shapes that are closed, right? So like our polygons in 2D or our solids in 3D, right? We say, well, there's a boundary there. We can see that there's a boundary, so it is bounded, versus when there's not, it's unbounded. So the big question is, why do we say that a circle is bounded in 2D but not in 3D? Anybody want to take a guess?
No, but I'm glad you asked that, because that was my question.
It had me thinking, I don't know the answer, but it had me thinking about perspective of like what someone sees as freedom, another sees as being bound. And so it's just interesting how the shapes, you know, in 2D and 3D, it becomes unbounded. And then the shape that's bounded in 3D becomes unbounded in 4D. So that's where my mind went with it.
So is it because in 2D that circle is a circle, but in 3D that circle could be a slinky? A
Pretty
circle that
much.
just goes up?
Yeah. So if I have, now I could define a bounded circle in 3D. So I want to be clear that it is possible to say, hey, here's a circle and it's only in this plane. So I might say x squared plus y squared equals 4. There's my equation. And then I might say, and z equals 1. And so now it says only in the plane where z equals 1 am I defining that circle. And then it's a circle because it is being bound by saying it's just in that plane. But if I don't say that, if I just said x squared plus y squared equals 4 in 3 dimensions, then I'm saying that has to be true for every value of z, for every plane, right, that stacks up below, above or below my xy plane. So if my xy plane is here and there's my circle, well, it has to be true in this plane and this plane and this plane and this plane. And so that's why we get this idea of an infinite cylinder, right, that is unbounded, because it's true for every plane in 3D.
Hmm.
So we can bound, we could have bound it to a region of 3D space, to one plane. But when we define it and then we say, okay, well, look at it in 3D, well, it's true for all of those values of z. Does that
So
help?
my slinky's even bounded in 3D in the sense that it's going to have endpoints. It's not going to be infinite. But I can imagine an infinitely long slinky that's radar cylinder.
Yeah.
Okay. So it takes our imagination, because I'm never going to see an unbounded circle. Maybe a ray of light shot out into space.
I would say that's your closest, but our universe does have boundaries. So there is, right, we don't really have in our physical world, in the physical creation, right, we probably don't have anything that's truly unbounded.
That's something you could do with your kids, and at night get a flashlight and get close to the wall and look at kind of that cylindrical effect, and then take them outside to talk about bound and unbound.
So when we think about that, and we can relate that to the idea of open and closed, when we talked about our inequalities, right? That we talked about inequalities being open or closed because of the way that we drew the circles, whether we had open circles or closed circles. If it was an open circle, so here's the difference, right? Is if I graph, let me just turn my pen on here. Get the pen out of its holder.
The English person in me is unnerved by the words bounded and unbounded as opposed to bound and unbound.
We're nodding. We agree. But in math, that's what we say.
All right. So we look here and we're looking at this segment, right? If I look at this segment here, we would say that this is right, open to the left, closed to the right, because we are not including that endpoint on the left and we are including that endpoint on the right. However, it's still bounded in both of these directions, right? Both of these are bounded, even though that boundary is not included in my interval. So whether or not my bound, so there's two different ideas, right? So my openness is talking about whether or not something's included in my solution, whereas bounded is saying, is there a limit? And so if this was 4 and 6, and we said 4 is less than x is less than or equal to 6, right? I'm saying that my left-hand side, right, my 4 is not included. So it's open on that end. It's not included in the solution, but it's still a boundary. X can't be it cannot be 4 or anything less than 4. So it's still a boundary, even though it's not included in my solution.
So we don't know if it's 4.01 or 4.000001, but it's something to the right of that 4.
Exactly. Right. So that idea of bounding things is related to sometimes these open and closed intervals, but they're also different ideas. So we can still have things that are bounded, even if they're not necessarily closed, right? It can still be bounded. So we could think of um, the sphere, where we say, I just want everything that's inside the sphere. So not the surface of the sphere, but it's still bounded. So lots of things to think about when we think about solid shapes and other shapes, right? And sometimes thinking about it in 3D can be challenging. And so that's where sometimes it's helpful to go back to 1D and say, okay, well, let me just look at it in a simpler case here in 1D and then build from there.
A good example of why we have these extra pages, I2 and I3, because you can see we've talked about lines and shapes the whole way through up to week 20. But this is one place to put all the information together that you've previously learned and review it when it's important for, because these concepts are really emphasized in polyhedra.
Let's go ahead and take a look at our cubed Memoria page. And as we look at this, I'm going to challenge you, which columns here are just representative of more things, and which columns might be have everything that's in it there. Does anybody know?
Are you trying to say that the
What's the
column on the
question?
left is super specific and that middle column has all kinds of shapes related to them?
Well, so are those all the possible pyramids? Let me ask it that way. Are those all the possible pyramids? No. Are they even all the possible triangular pyramids? No. Are they all the possible prisms?
No.
No. But are those all the possible platonic solids?
Yeah, that's it. We're done.
That's it.
I like those kind of columns because if I forget the other two, I at least have 5 things I know.
So does that mean the last column is bounded because there is a limit?
Yes, there you go. I like that, Babs. Yeah, and we're completely unbounded when it comes to the pyramids and the prisms, right? We could keep going ever and ever. So just by looking at these, right, and this is a Memoria page. So what are some things that I might want to memorize on this page?
The formulas in the platonic solid column.
Yeah, so those formulas. So I'm going to let you in on a secret that those formulas in the platonic solid column, I have not memorized because that is information that I would probably go and look up personally. But I would want to maybe memorize the lateral area and surface area information for the pyramids and the prisms. So
And
I'm
just
not
so you know,
saying
within the lessons that what Kirsty just said, they get to see one problem with each of those on the right where they're so difficult. But on the left, we have all kinds of problems with all kinds of numbers, so they can practice thinking through all the variations.
now what would be a good thing, and I'm not saying don't memorize that. Please don't hear me say that because it's not bad to memorize it. I'm just saying that if you were prioritizing what you were going to memorize, that would probably not be first. However, the names of the platonic solids might be worth memorizing. And if we were to look at those volume and surface area formulas, though, for the platonic solids, something that might be interesting to note is that how many variables are there in each of those expressions?
2. 1.
Where you're
On
looking
the
at?
right,
On the
yeah,
right hand.
there's just one, and it's the side length, right? So notice how because of how we would define a platonic solid, we know that all those sides are going to be congruent. Those edges would be congruent, that side length. So that's kind of interesting, isn't it? That if all I know about the platonic solid is the number of faces that there are, that it's a platonic solid, and what the side length is, I can calculate its surface area and volume. And it's not, while some of those, I'm going to be honest, right? Some of those calculations look quote unquote ugly because we've got, you know, double square roots and different things going on. It's not as bad as it could be. So they're really fairly elegant equations.
Just as someone took the time to do enough different volumes of a icosahedron to say, huh, same ratio every time. I guess this is the formula, right? Somebody
Oh,
did that.
so you saying the word ratio just made everything click for me. So thank you. I got that. So when I look at this, of course, when I first look at it, I'm like, whoa, that looks like a lot of funny words and symbols and stuff. And then the basis is at the bottom and all this different stuff. But the more I read it, the more I just see like 1/2 base times height. And it's the same thing we've been memorizing. It's just 1/2 and then what measurement of the base times which measurement of the height am I looking at that right?
Yeah, so that's, you're absolutely correct, right? And especially here where we think about right, the pyramids, and we're talking about that lateral area because all of the faces of a pyramid is what kind of a shape?
A triangle.
Triangle, right? So it's all going to be based off of a triangle.
So even when we move to the cube or to the rectangle, it still looks familiar, right? Because, well, to me, once I look at it enough, I still see base times height. Or, if it's a cube, I still see the area of a square is the length of a side squared, S squared, right? So I still see that stuff here. It's just expounded upon. So I'm trying to figure out how to help my kids see, because we're on week 17 now, and we were looking at the same kind of thing where it's like, look, this is just the formula. If you take LW, that's length times width. You've memorized these already. And then she was like, oh, and this is just, when you plug in the cosine of something, all I'm doing is plugging it in and multiplying it. But it looks super complicated when you're looking at it, and you're like, you're doing complex math with very simple understanding because you've been looking at this for the last 10 years.
Yeah, Nicole, that's such a great point, right? The more familiar we are with the 2D, it's helping us now to understand the 3D. And it looks confusing when again, going back to that symbolic notation of math, we are still working to decode it, right? Until we become fluent in it, we're still working to decode it. And that's why it looks overwhelming. But you just said, hey, take what you've already learned, right? We memorized this in foundations. We've looked at it in earlier lessons in the 2D lesson. So now, right, use this to make this familiar. And that's exactly what we're doing with classical learning, right? We're taking those pegs and then we're making connections. So that's great that you just did that.
Well, now I feel all smart and stuff. Thanks.
All right. So I'm going to push us on to looking at our charts. And as we look at our charts here, you're going to hopefully see some familiarity here between what we just looked at on our I squared and I cubed page to now taking a look here. And so we could ask our students, right, what's familiar and what's unfamiliar. But it's also, I think, looking at these two pages of the charts, and they're back to back, so you can't really do it side by side. But if you could look at them side by side, let's look at them comparatively as we look at these side by side. And what are some things that you see that are similar, right? If we compared these two pages, how might that help us to understand what we're looking at?
Well, they both have a big shape in the left top corner, and they both have cylindrical shape, pyramidal shape, and an unusual shape in the same order.
I think I noticed that they both have I guess those are definitions, like terms and their definitions. And I like that because we keep going back to what is that? What is that? So having a place where we know we can go and look at the find that term is helpful.
In comparing the two, it seems that the one has to do with polygons as a base, and the other has to do with circles and ellipses as a base, with the exception of the frustrum, which shows both.
Ah, there's the frustrum. Okay. Mhm.
We have in the layout and then on the left side, top center, you have those things that look like diamond rings, and on the right side you have footballs. So there's some sort of unusual shape you're going to take a gander at.
And how about when we look, if you looked at the prism and then the cylinders and then the pyramids and the cones, are there some words that right, there's pairs there. What are the pairs of shapes that we're looking at in each of those columns?
Right and oblique. So what you're getting at.
Mhm.
So we've
Mhm.
got a right prism and an oblique prism, a right pyramid and an oblique pyramid, a right cylinder and an oblique cylinder, a right cone and an oblique cone. So if we start to notice these patterns, is that going to help us to understand what right and oblique are?
Yes.
Right. So who was it that said that they were really a word person? Is that you, Nicole? Right. So as we look at this, we start to see just how we can, right? We build words with syllables, and we take, especially when we think of how we take Latin words and start putting them together to get where we look at the roots, right? To say, how did this word get built? Well, it's the same idea here. As we look at the names of these shapes, right? We can talk about it, whether it's right or oblique. Then we can talk about its shape, right? Is it hexagonal? We omit circular, right? But we might say elliptic if it wasn't circular. And then we say, is it a prism, a pyramid, cylinder, a cone? And so we're building a picture of what these shapes are by putting different words together. And so when we look at the charts, in this case, comparatively, right, there's going to be times where we see that this is going to help us to understand how that happens, right? How all of these words, using that word right or oblique in many different cases. It's not 4 different cases, it's the same each time.
Interesting.
The other thing I like about this lesson in particular is the only real math is length, area, and volume. That's it.
Mhm.
Very simple math, but applied to very complex shapes. So of course, throughout the domains of the math map, we start with just, triangles and squares in the back when there's 2D. And now when we get to 3D, we use some of these for the little guys, but we mostly just have them finish the equation or copy the equation, color the shape, count the sides, count the edges, just so that they learn to look at the shape. So I know some people have told me that there's, the copying can get to be tedious for the little kids, and I don't disagree. Sitting at a table copying for a long time is hard for a little guy. But if they just get 2 pages of copying done and then go actually play with their Legos in a lesson like this, they're going to start to see things whether you know it or not.
Mhm.
Because we're
Mhm.
examining closely at their skill set. But with the older children, what Kirsty just took you through, it's really important so they can start to go, you mean there's just 3 things I have to know about each of these shapes? And then for the platonics, there's just really 1? Because it seems overwhelming otherwise.
Mhm.
All right, let's go ahead and we only have a couple of minutes, but does anybody have a testimony? And it should say week 19 open shape, so I apologize for that. But does anybody have anything from week 19 or a testimony that they'd like to share this week?
I did want to tell Jackie that I did reach out to Jana, and she was not the one who made the suggestion about the motions. So I'm not sure who made the suggestion about motions, but she didn't know anything about it. So
Yes, thank
anybody?
you, Babs. I got your email and I thought, oh, I'm going to go back and watch that video. And I haven't had a hot second to do that yet. But I am in the process of tapping into my inner foundations creative song maker. I never made a song before. But I'm putting the unit circle to a song, and I'm gonna have my students memorize it.
Very
So
cool.
I have one quadrant done, and I sent it off to Rachel, who's a good friend, and said, "Hey, does this track?" You know,
Love the creativity.
Yes.
Oh, and isn't that perfect? Because we were just talking about foundations yesterday, and right, the whole idea behind foundations is to prepare us, right? Or maybe one big idea about foundations is to prepare us for challenge. It's not, oh, I got through foundations and I'm going to dump those ideas, right? But that we're practicing the skill of memorization. And that's right, that half hour where the foundations tutor is saying, we're going to say it and we're going to jump it and we're going to motion it, right? That it wasn't, oh, that's just good for you when you're little and then forget, but that those are all tools that we can use to help us memorize, even in challenge A and B and 4, or even right when we get into our college programs or our master's programs, right? So um, that we don't want to stop using those tools just because we're in challenge. We want to continue to practice those tools and build on them with our students and help them to see that no, we learned that because these are really great ways to memorize things. And you're always going to be given new grammar that you want to incorporate into your Memoria. And so use these tools. So I appreciate you sharing that.
Mm.
So as Lee pointed out, as we look this week at our exercises, there's going to be some counting, and a lot of the math is going to be really using those formulas for calculating different measures, right? There's not necessarily quote unquote hard math, or the math that we're really looking at, the new math that we're looking at this week is less about computation and more about the concepts and the names of things. So as we look here, notice we're tracing our shapes. We're not, we're going to start there and build a familiarity with these shapes. And we're doing this in 2D. So if at home you have a shape set, it would be great to pull those out and have your student actually look at a tetrahedron and hold it in their hands while they're tracing it in 2D, right? So that same idea that, Nicole pulled out, our flat maps to our spheres, our globes, taking these flat images of our shapes and actually giving our students some things to hold so that they can actually do that at the same time is going to help them to really get a three-dimensional understanding of these shapes. So as we look at these, so we're going to name them. They're named by their faces, right? So here's my tetrahedron. Tetra is 4. And so we have 4 faces, and I could count those. And again, this is where it may be easier if you have some shapes that your students can hold for them to actually count it. Otherwise, you might do it as you're tracing, right? So here's one face, and I'm going to go ahead and trace over because there's the back face. That's 2. Here's my third face, and then there's my bottom face. So even though it looks messy, it may be helpful to have your student actually trace each of the faces as they're counting them. So there's 4 faces. I have 1, 2, 3, 4 vertices. And again, you might want to trace over it. You might want to choose a different color. Let me do that. Right. So now I might say I'm going to count my edges. So I have 1, 2, 3, 4, 5, 6. So this is a case where tracing may actually help your student to keep count because we've got all these things that are kind of on top of one another. Then notice it says to verify Euler's formula, which is faces plus edge vertices minus edges is 2. And so we're going to take our each of these and bring them down, our faces, our vertices, and our edges, and it's true. And we're going to see that it's true for all of these, but we're going to continue to help students to practice that because it's going to also help them to catch any errors that they may have had in their counting. So I may not always name first. I may count my faces first. So if I look at my next one on the right-hand side and I trace, I've got 1, 2, 3, 4, 5, 6, 7, 8. I have 8 faces. Notice this time I'm not counting that square in the middle because that's internal. It's not on the outside, so it's not a face. So I have 8 faces. So this is going to be my octahedron. Octa for 8. Now I can count my vertices. 1, 2, 3, 4, 5, 6 vertices. And now my edges, again, you may want to trace. So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so if I fill in my blanks, my 6 and my 12, notice that's true, right? So if your students are doing this and they put their numbers in and it doesn't come out as true, then they know they need to go back and recount what they were doing. If we look at page 2 here, we're now looking at some different shapes. So here we might recognize that on the left-hand side, what kind of a shape is that?
Sphere.
Here.
And there's something to
Sphere.
point out at the top, it says properties of non-polyhedra. So that means it's on the chart that says properties of non-polyhedra if your student doesn't remember the names.
So as we look at our sphere, what's the radius of our sphere?
6 centimeters.
6 centimeters. So I'm going to go ahead and write R equals 6 centimeters because now I'm asked to find the surface area to calculate the surface area. I'm told that it's 4 times pi times the radius squared. So now I know what my radius is, so I can substitute that in and then I can calculate. Notice that I'm leaving everything in terms of pi because I want my exact answer. And so all I have to do is say 4 times 36. And 4 times 36 is 144. And so my surface area is 144 pi centimeters squared. Now the shape on the right, is there anybody that's familiar with that shape?
Only because of Math Map, the torus.
It is a torus.
The donut.
It looks like
Looks
a
like
hose.
it does, a hose that's been closed back onto itself.
Mm-hmm.
That would
So
be a
I
torus.
want, now when I give people baby shower gifts with the stacking rings, I want to label it the torus stacker.
Mm.
That's fun. So notice we have 2 different radii that we're going to consider here. And so we have this big R, which is the radius of sort of the whole shape from the center out to the edge, which in this case is 8. So I'm going to go ahead and put my 8 meters here. Then I have my inner radius, right? And so that's just sort of like the diameter. If you think about it as the radius of your water hose, in this case is 2 meters. And so now as I look at this and I want to do my surface area, I can simplify my meters times my meters is 8 is meters squared. 8 times 2 is 16. 4 times 16 is 64 pi squared meters squared. So notice the calculations are not necessarily super challenging here because we're practicing what the equations are by substituting in. But what we're also practicing is attending to where are those measurements, right? What is it that I'm measuring here? What's my shape and what am I measuring? So it's good practice in attending here as we're working through. So as we're looking at the skills that we're practicing, I'm practicing attending. So we want to continue to remind you and the students, right, that we have solutions, and working backward is a good strategy, right? That if you're not sure what to do or why something is true, that looking at the solution and working backwards is valid, right? So my master's students, right, their assignments that they have to do each week have answers that are in the back of the book, so that they can go and work backwards and check their work if they're getting stuck.
Can I
Right.
just say praise the Lord for that right there? That they have answers that you can work backwards.
Our inside back cover, we've got those questions to extend the conversation and fill that lesson 29 booklet. That may feel, as we're moving into these last sort of third of the year, the concepts are going to gain in complexity, but the lesson pages, I think, are perhaps in some ways less demanding, right? The concepts are bigger, but some of the calculations are less demanding as we move on through the year. And so this may be a place where your family now has some margin to say, hey, let's look at that back page and see if there's something there that we want to pull in and integrate, right? We certainly encourage you to continue playing games and using the flashcards as just the best way to load the grammar and practice it. Continue to use that calculations page. And then the companion is there. So we're getting close to having all of the lessons in the companion. So that continues to be there to be a resource for you. And just a reminder that all of the charts have content. So you can click on different parts of the chart to get more of a math understanding. So if you as the parent is going, well, why is this? Or I want to understand more about the math, that would be a good place to go. And then we're slowly going to be building out the lesson pages and giving you more content there. And then notice that the lesson pages are not are last. That doesn't mean that they're least, but we did put them last for a reason, because we really want to emphasize that if you skip the rest of it, right, and you just go to the lesson pages, you're going to miss out, right? That the lesson pages need to be a part of what you're doing in your day at home and not the only thing or everything that you're doing. And then don't forget, we are here to support you. And Babs or Shauna, I'm not sure, have we got a Challenge B forum that is now live for those directors who are moving into B?
We do.
Yeah,
Thank you.
so I will have to add that. So yeah, so if you are looking ahead to Challenge B, the Challenge B forums are now have some places that you can get some more information about the math map. And with that, I'll open it up to questions.
Actually, I have a question about that, Kirsty. Thinking ahead to next year with monomials, does the book club continue moving into monomials, or what does that look like?
So Lee and I just talked about this yesterday, and what we are thinking it's going to look like, because we want to try to always give people something different in each version of the book clubs, right? So we've got that original book club that was the exordium, and the charts was really our emphasis. Then we went through the naturals and we looked at pages 1 through 4. Last year, over the summer, we did some different things with dimensions and the quadrivium. And then we've been talking about in community, what does it look like using complex? Next year, if you're in monomials, you could come back and watch this year's recordings because it's going to be the same. The only difference is going to be looking at those page tops, and the way that Lee has it designed. Complex and monomials are very similar because, right, we want it to be this gradual growth over the years. So it won't be the same format, but what we're thinking, and so don't hold me to this because we haven't exactly fleshed it out, but what we're thinking we may do next year is take a look at perhaps our the other domains that we're releasing. So perhaps sometimes integers or fractions and monomials, and look at those together and with more of a focus on what might this look like at home. So where we've emphasized in community this year, we might look more at home, right, next year.
Sounds great. Thank you so much for offering this. It's been so helpful.
It's been a joy to us to be able to meet with all of you each week and just to see, right, see how we've all grown in our mathematical understanding.
Quite frankly, your questions and your faithfulness are such that we feel like you're really quite an advanced group. And we want to make sure we have videos for parents who are like, it's the first time and I hate math and why are they making me do this? So we want to have, variety for all kinds of folks. But Kirsty and I have been so challenged by you guys this year, and you have improved the release of each of the next levels because of your questions. So just thank you so much.
Well, I have a question. So I was listening so hard to what you were saying that I forgot my question. Um,
I'll ask a little question in the meantime. You may have told us this before, but for some odd reason, I must have missed week 19 and I have no notes on it and I don't know where I was. Can I go back? Is the video from week 19 available somewhere? Is it out there, Babs?
It should be accessible through Lee's website. If you click on the archive, and if you for some reason can't find it, if you Babs may be able to post the link in the chat, or the other option is if you don't get it right now, then you can always email the math map at classicalconversations.com, and Babs or Shauna are super fast at getting you that information and shooting it back to you.
Thank you. I've never had to go back and look for it before. Maybe I just left the universe for a week. I don't know what happened.
that's hilarious.
And also
Okay, I remember
Peggy too, in all those forums like Foundations, Essentials, Challenge A, Challenge B, there's one thread that says Lee's Book Club, and all of those are there too. So every time the recording is up, I go add it there too. And then I put a link. There's a what we have on Help Scout. You can access that one too. So there's several different places. But you can just go to YouTube and search Math Map week 19 and it'll come up there too.
That's cool.
Cool.
I don't think I
Thank
knew
you
these were
very
on
much.
YouTube. I don't think I knew these were on YouTube, but my question is about so Lee said something like, what about the people who this is kind of new for, or they're still feeling like they don't know what to do? And even though I've been at this for a while, I do sometimes still feel that way, mostly because I have 3 students doing the math map. So I'm also the book rep for our area, and we're getting ready to do these math map at home events that are half-day events where we get to talk through, and I'm still waiting for the content of that. But because I'm doing that, I'm all the more interested in getting it right at home because I'm a great example. I have a Challenge A, I have a second year Essentials, and I have a Foundations only. So my question is around all the different things that are offered. Actually, 2 questions. So the first one is, you're saying like the pages, when you said the pages should be just one of the things that we do, I kind of was like, oh, because that's really the main thing we do. But like we sometimes do the math cards. And then today I realized we haven't done any of the games on the back. Just this morning, I was like, oh, there's a game on the back I keep forgetting about. And so I just can't seem to fit all that in an hour. We do math for about an hour and 15 minutes because in order to do the 15 minutes of flashcards, I just can't seem to get everything in an hour. So I would love for you to kind of just give me advice about what would you say to a person who asks you this at an event where I have to give the answer? Because I'm feeling stuck. I'm not stuck, but I love the math. I'm doing great, but I just feel like I'm not getting the most out of it.
Yeah, so I mean, Kirsty can add to this too, but there's no way to make something that's all things for all people. And there's folks like yourself, Nicole, where the parent will really dig in, and going through the lesson pages isn't a problem. It's fine that you're doing that. But we wanted to make sure that there was something for everybody. So for those that want to learn how to see God, we have the art and the this conversation. And then for those that like to play games, we have the back 2 pages. For those that want to have a quiz each week, we have the careful calculations. For people who want to just say, don't give me any problems, just give me the chart, we've got that. So all those parts are just to cater to different personalities and levels of achievement, all in one place. So you putting an hour and 15 minutes a day in, it doesn't almost matter what you do. Your kids are going to be fine because you're putting the time in and the work. It's just like dribbling basketballs. Eventually you're going to be able to, pass it also. So, well, what Kirsty was saying earlier there that I do think is important is if your children think math is always turning pages, you've robbed them. And we adults on this book club have learned that, right? We're now, like you're saying, you just see it everywhere. We want our children to see math everywhere. So doing more so maybe skip the pages if it's a book that's really easy for you at this point, or the kitchen flooded, whatever it is, and maybe just do games that week. There's all of it is good exercises and activities.
Okay.
Yeah, I think if you think about it as so 2 things. We've been taught falsely, and I can tell you this as a former classroom teacher and as a mom, we have been taught falsely that math looks like a textbook that goes from page 1 to page 396, and that you read something and then you do some problems, and you read something and you do some problems, and that's how we move through math. And that if you're going to be successful, you need a teacher's guide that has little examples and answers in the columns, right? And a classroom teacher, that's what their expectation is. And so one of the things that we're trying to do is kind of uncouple learning about math from that textbook based idea, to say, right, as Lee just said, there's so many different components. It's going to take a little bit of time as a parent for you to have the confidence that you don't have to do it all, that you can tailor the curriculum to your student. But we didn't want to write a curriculum, right, that assumed that nobody could do that, right? Lee didn't want to say, oh, our parents are too stupid. They need somebody to hold their hands and walk them through this. Lee believes, as do all of us, right? We believe that you as parents can lead the math education in your home, that you can rightly assess what it is that your children need to be excited about math, to start looking for math around them, to gain fluency in calculation, to gain fluency in the language of math. And as Lee pointed out, that's going to be different in each family, and it might be different in each student, and it might be different from day to day. And so there may be days where the lesson pages are the most effective way for you to work through the curriculum with your students. But it's okay if there's days where you don't get the lesson pages done, but while you guys went on a nature walk and you talked about all the different solid shapes that you saw, or you went and took a microscope outside and looked at a snowflake and saw the amazing symmetry of the snowflake. That's still a math lesson, right? Even if you didn't necessarily check the box of getting your lesson pages done. And so what we've tried to do is to give you a smorgasbord. And if you think about going to some kind of a buffet restaurant, right? And this is what we all do, right? The first time you go to a buffet restaurant, you're like, oh, I want some of that. Oh, and I want some of that. And I want some of that. And we start piling it on the plate, and we start piling it on the plate until we get this plate that's so full that we sit down and we're like, oh, I don't know what to start with. And then we get halfway through the plate and we're full, and we feel guilty because we didn't try this and we wasted food. And all right, well, that's kind of how we start off with the math map, is like, we want to do it all and we try to cram it in, and we're doing 3 hours of math and we burn out. And then, so if you can think about the better way of going to a buffet restaurant, right, is to say, okay, take a plate and go and pick a couple of things and just get a little bit and try it. Oh, I really like that. I'd like more of that, right? Or I didn't like that so much. That didn't help me learn. So maybe I'm not saying I won't do that, but wow, the flashcards were really effective and the careful calculations weren't meaningful today. Well, the next time you go back, it may be the careful calculations that taste really good. And so you don't have to have everything on your plate for every day, right? That you can pick and choose, and then the next day you might do the same, but the third day you might go, we're going to try a different part of the buffet today. And it's going to take time for you and us as parents to gain the confidence, right, to be able to leave
Yes.
things and pick and
Well,
choose.
and I'll say that you guys believing that we can do it, you believed more than I did. Like I absolutely did not believe it. And I have a 19-year-old to prove that I did not know how to do this before. So thank you for that. My second question is really around, I think you've kind of answered it, but it's around like we're doing the math map, and I like to use the answers, and I've told my daughter you can use the answers to work backwards, right? So I got that. But what I noticed lately is that she's going to the answers, writing in the problems, looking them over and saying, I still don't get it, and then just moving on. So is that okay? Like, am I still like, do I just say, okay, we'll get back to that later? Like, or do I break it down? I've been like breaking it down to her, which has been horrible. It's been like turning math into way too long. And she's like, Mom, you're so intense. I'm like, I know, but I'm so excited that I get it and I want you to get it. And so, yeah, just speak to like how much of that does she really need to understand, especially being already in challenge A. You know, my challenge, my foundations essential son is like, I wish I had been doing this since Nicholas's age, because Nicholas is only 8, and he's like, I think I would get it better if I had already been doing this, which is what I think you had told me before. But Naomi's already in challenge A, and I'm like, how much of this does she really need to understand, or how much of this do I just say she's going to do this 6 times and it's going to be okay?
It's
Well, how many times does it take to memorize God's word? I mean, and how many different ways can you memorize it? And then you could memorize scripture and never know Christ. You could memorize scripture and never apply it to your life. You could sit there and apply it to your life, but never memorize any of it. Right. So look at how you study God's word and the things that are best for each person, and getting to know him better and hiding it in their heart, as well as applying it and doing what we're saying classical education does. It teaches you to name like Adam, ask questions like Jesus, and persuade like Paul. That's what you want them to be able to do with their math curriculum. But no one's going to do it all at once, and it's going to take a couple decades to be able to do all 3. Right? So it's
Nicole,
just, go ahead, Kirsty.
I was just gonna say, but I don't want Nicole to go, I don't have a couple of decades for my older students, because
No, you absolutely do. You
but
absolutely do. We have till
yes,
eternity to get this right with Christ. Right.
because
So
your
sorry to
goal,
contradict
yeah.
Kirsty, but it's
Well,
it's
no, I just
true.
wanted to address that because I knew that was the thinking that she was having. And I just wanted to say, right, think I've got 6 years, not for her to master mathematics, right? But I've got 6 years for her to look at math classically. And I've got 6 years for her to learn how to name and attend and memorize and express and tell stories and um, define and compare and look at the relationship and the circumstance and the authority. And then to go, okay, what's in my Memoria? How do I think about this in an inventive way? How do I arrange this? And then what's my delivery and elocution look like, right? So those are our 15 skills of learning, and that's what we're trying to teach. And so you've got 6 years to develop those skills with her using math, so that then for her entire lifetime, just like you, right? You're going, I'm starting to get this. Well, she might be 30 when she starts to get some of it. She might be 20. She's going to get some of it in the next 6 years, right? But we don't want to look at this as a bounded, right? Here, let's go back to where we started, right? Math education, has no upper bound on it, right? And
Right.
so it's not going to be finished at challenge 4, whether they go on to do math in college or not. We want them to continue to recognize, right, that math is inherent in creation, and that as we continue to look at mathematical ideas, right, whether we do it formally or informally, we're using these same skills of learning to continue to learn about math. And so that's where Lee says this is a lifetime thing. Practically, I want to encourage you that yes, there's going to be a lot that you don't understand this year, or that your daughter doesn't understand this year, that you will over the next 6 years go, oh, now I get it, right? Even if you take it and you come back in 3 weeks, you might go, oh, now I get it, right? I was stuck and I took a break and I came back and I get it. But where you're excited to work through something and she's going, maybe each day say, I want you to pick one thing that you were like, I just didn't get it. And we're going to look at that more deeply together, whether it's you working through it or whether it's you using those skills of learning, saying, hey, well, what can you name in this, right? What is there a pattern you can attend to? Do you see a pattern here? Is there something here that's worth memorizing? Right. So go back to those skills that we keep talking about and say, you pick one thing, and now we're going to pick some of the skills and we're going to look at see how those skills might help us to understand it. Whether she ends up understanding it or not, right? That's what we want. What we want to be doing is saying, okay, well, let's use your skills to work through this. And it may lead you to some new understanding today. It may not, and that's okay. But that's what we're aiming to do, is so that the next, right? So like, let's say you did that for the next 10 weeks. And then all of a sudden she goes, I don't need you, Mom, because I asked myself the same questions, right? That's what we're trying to get to, is teaching them to ask themselves those same questions and use those same skills to start understanding.
Okay. That's helpful. I think you've probably said that a million times before, but that's helpful.
You can't say it enough times. We have so much damage to undo.
Well, one last thing, we were in the car, and I don't know if you guys have heard this song called Counting My Blessings, but it's like 1, 2, 3, up to infinity. And my son goes, Mom, that's math. So I thought that was pretty cool testimony that he's like, oh, wow. Like his math map is working, I guess.
And you have a beautiful voice. Can I just say, like,
Oh,
yeah.
thank you.
So, thank you. That blessed us.
Okay, well, looks like I know I'm out of time, so I'm going to get off. Thank you, everybody, for being with us.
Thank you.
Good.
Have a great
See
week,
you.
and we look forward to seeing you all next week when we talk about locations.
All right. Ooh, fun. Bye.
Thank you.